In this video, I'm going to have a look at the 2007 higher level paper. I'm going to have a look at the chemical equilibrium question there, which came up again in the, the question that you pick 2 of 3 parts. There's 3 parts in question 10. You do 2 parts. So the first one here is on chemical equilibrium. You've got one here on gases, and you have one here on oxidation reduction. So you do 2 of the 3. This is a half question. There are 3 half questions. You do 2 of them to make a full question, 1 of your 8. So I'm just going to have a look at part A because that is chemical equilibrium. You can see here that we have write the equilibrium constant Kc expression for the reaction below, and the 7 marks going for it. So I mentioned that there's loads of questions like this one where you write the equilibrium constant expression for 6 or 7 marks usually. So, and they've also told us some more information with regard to working out the Kc expression or the Kc value afterwards. So 12 marks for that part. So I'll just do the first part, and I have written down the equation here. So if we're writing down the Kc expression, I'm going to do it over here on the right to give myself some space. So the Kc expression, all you need to do is you need to put the product on top in H3 and put it in square brackets and put it to the power of the number in front. So in this case, to the power of 2. And the reactants go below. So N2 square brackets and H2 square brackets, and the H2 has a 3 in front of it, so it's to the power of 3. And that's the answer there for 7 marks. That is the Kc expression for this reaction that we talk about so much, the production of ammonia, which is one of these reversible reactions where you get a state of chemical equilibrium being formed. The next part of the question is to work out the actual Kc value. So you can see here that it says that there are 3 moles of nitrogen gas and 9 moles of hydrogen gas mixed together at the beginning in a 1 liter vessel at a certain temperature T. There were 2 moles of ammonia in the vessel at equilibrium, and it just says calculate the Kc for this reaction at this temperature. They have to tell you a temperature because Kc is temperature dependent. So for that reason, they have to tell you a temperature, even if it's just been given the letter T, we know that it's staying the same. So how you do this is, I like to construct a table, and what I'm going to do is I'm going to write down initially, or at the start, and then I'm going to say used / formed, so depending on which side of the equation we're looking at, it'll be either used or formed, and then at equilibrium. So at equilibrium. Now, depending on the question, you may have to include a per liter. Now this is in a 1 liter vessel, so we don't have to worry about it in this question. But just to show you how this works, initially you had 3 moles of nitrogen gas. So initially you had 3 there, and you had 9 moles of hydrogen gas, 9 moles there. And initially there was none of the ammonia present. So you had no ammonia at the start. Now for the used / formed, and this is kind of where my method of doing these questions is a little bit different, and I think it helps a lot. I like to put in, if it's used, it's minus, and if it's formed, it's plus. Okay, so, and the used ones, these 2 get used because they're on the left hand side, and this one gets formed. So for the used / formed, I use the balanced equation, and I just use an arbitrary figure like x, and in this case, the number in front. So here it would be 1x because there's no number in front of that, 3x, and 2x. Okay, so that's just using the balanced equation and saying that x is the quantity, the ratio that goes across all of these. And at equilibrium then, what we would get is we would have, because the formed is added, so 2x plus 0 gives you 2x. This would be 9 minus 3x, and this would be 3 minus x, if that makes sense. So you are subtracting the x amount from the initial amount on the left, and you're adding the x amount to the initial amount on the right hand side. Okay, and that might be, a little confusing, but it really helps with working out all the rest of it. If we look at the, I suppose, the next line of it, there were 2 moles of ammonia in the vessel at equilibrium. So at equilibrium, they're saying that the ammonia was 2 moles. Now, from looking at this, you can clearly see that our x is 1, because if 2x is what we found out the ammonia to be in x's, and we were told that it's 2, then the x is equal to 1. So we can fill in for x, and if we put in 1 in there, 9 minus 3 gives us 6, and 3 minus 1 gives us 2. So these are the values we're going to now use to put into our Kc expression to work out our Kc value. So we're just going to take our Kc expression, and instead of this, we're going to fill in these numbers. So our Kc is going to be in H3, well, that's our 2, and that's in their square brackets with a squared. The N2 is 2, and that's in square brackets. And the H2 is 6, square brackets, and that's cubed. And when you work that out, you get 4 over, that's 6 by 6 by 6, multiplied by 2. The answer comes out to be 432. And when you get that into a decimal, I think it's something in the region of 0.09. And that's how you work it out. You could keep it in the decimal form or the fraction form of 1 over 108. And that is the answer there for part 2 of the question. The last part of the question, part 3, says that Le Chatelier, pictured on the right, studied equilibrium reactions in industry in the late 19th century. According to Le Chatelier's principle, what effect would increasing the pressure have on the yield of ammonia at equilibrium? And explain for 6 marks. So, increasing the pressure. Now, for part 3, we're looking at this. So, again, we go back to the balanced equation, and you can see how many molecules are on the left, how many on the right. So here we've got 1 and 3, and over here we've got 2. So there are fewer molecules on the right than there are on the left. There's 4, 3 and 1 here on the left. There's 2 on the right. So increasing the pressure will move the equilibrium forwards or to the right. Increasing the pressure increases the yield of ammonia. It's 2 M's. Okay, and that's what the effect is. And explain, well, it's because there are fewer molecules on the right than there are on the left. And that is the explanation. That's for the other 3 marks. And that's the half question 2007 from the Leaving Cert paper.